Previously, we discussed how to solve equations for one variable. Today, we're going to talk about how to solve systems of equations where there may be more than one variable involved and we need to find the value of both. So first of all, we know that systems of linear equations are going to be created by two lines. So you do have to start by having lines. If we talk about systems of quadratic equations or systems of cubic equations, it does start to get a little more complicated. So know that we are sticking for the moment with lines. Okay, a solution to a system of linear equations in two variables is an ordered pair. You should think point xy that satisfies both equations in the system. So let's take a look at an example of what I mean by that. Okay, well, I'm kidding. A linear system has one solution, it's consistent, and if it has no solution, it's inconsistent. So these are two vocab terms that we're going to be using throughout the lesson. So again, if it has at least one solution, it's consistent. If it has no solution, it is inconsistent. All right, now let's take a look at an example. I want to decide if 1, 2 is a solution to the system 2x minus 3y equals negative 4 and 2x plus y equals 4. So what I'm going to do is I'm going to plug 1, 2 into each equation and see if it is true. So for example, I plug in 1 to the x and 2 to the y into the first equation. I get 2 times 1 minus 3 times 2 equals negative 4, question mark, because I don't know yet. That gives me 2 minus 6, which is negative 4. So you'll notice I write my question mark every time I check, and I usually put a check mark next to the final answer to say, yes, it works. Okay, so that was true. And again, I do the check mark instead of saying true. Up to you which way you do. We're going to also have to check in the other equation. When we plug in 1 to the x and 2 to the y, it does come out correct. Because they are both true, we can say that 1, 2 is a solution to the system. So if it's a solution to both equations, it is also a solution to the system. So pause the video while you check to see if 7, 6 is a solution to the system. So when I plug in 7 to x and 6 to y in the first equation, I get 14 minus 18, which is negative 4. So yes, that worked. I still have to check my second equation. So I plug in 7 for the x and 6 for the y, and I actually get 20 equals to 4, which is not true. Okay, it's false. Therefore, since it failed in one equation, it fails for the whole system. 7, 6 is not a solution to the system. And therefore, because it's not a solution, we may have to go find the solution ourselves. Now, how do we solve a system? Well, one of the options we have is by substitution. In order to solve a linear system by substitution, we're going to start by solving one of the equations for one variable. Okay? If you already have an equation that's like y equals or x equals, and that's already by itself, then you don't have to do it. Okay? They would have already done the step for you possibly. Then you're going to substitute what you got in step 1, or what was given to you, into the other equation. Now you're going to solve what you have left. It should have one letter left. Okay? Now you're going to back substitute. That means plug your answer back into one of the original equations. Okay? And then you're going to check. So notice that you're going to have, at the end of this, both variables' answers. So let's try solving this one. I tell you I want to use the substitution method. That means I need to first get one variable by itself. Looking at this, I don't have a variable by itself yet. So I think to myself, okay, which thing would be easiest to solve for? I'm thinking the y in the second equation. So I'm going to take the second equation, I'm going to get y by itself. So I'll subtract 2x from both sides, and I get that y equals negative 2x plus 1. That'll be much easier to work with. So then remember that step 2 says we need to now substitute that expression into the other equation. So I'm going to take negative 2x plus 1 and replace the y in the first equation with that value. So instead of 3x plus 2y, I have 3x plus 2 times negative 2x plus 1. In parentheses, don't forget the parentheses, equals 4. So I've done my solving for one variable, and I've substituted back in. Now I need to solve what I got for the variable that's in that equation. So I need to, in this case, solve for x. So in order to solve for x, I'm going to distribute my 2. So notice that 2 times negative 2x gives you negative 4x, and 2 times 1 gives you 2. Then I'm going to combine like terms. 3x minus 4x is negative x. Then to get x by itself, I'll subtract 2 from both sides. And then I'll divide by negative 1. That gives me an answer of x equals negative 2. Remember that you're not allowed to stop here, though. Because a system of equations, your answer has to be a point. In order for your answer to be a point, you have to know both your x and your y. So we need to back substitute what we just found into one of the original equations. So let's say I use the top equation. It honestly doesn't matter which one you use. So good fact for you. I'm going to plug my x equals negative 2 into the x value. And I get negative 6 plus 2y equals 4. I add 6 to both sides. And I'm going to get 2y equals 10. Then I divide by 2 on both sides, and I get y equals 5. So now I have the answer negative 2, 5. Notice that this slide calls it a proposed solution. That's because I still need to check it. Now I used the top equation to find my y value, so I'm going to check into my second equation, okay? So again, I don't require that you check in the first equation if you use that already, but I do require that you check it in the equation you didn't use to solve the second variable. And you'll notice here that when I check it, I not only put the question marks at the ends, but I make sure to show each step, and I say, yes, this worked out. Again, you can write a check mark or true. And because it works, you may box your answer. Negative 2.5 is indeed a correct solution. Now, another method we can use is called addition, or sometimes you'll hear it called elimination. Both are valid descriptors. When you're trying to solve a linear system by addition, you need to solve either the equations in these are not the correct steps. These are the steps for substitution. Ta-da! Nope. All right, so let me give you fresh steps. Step 1. Multiply each equation. So the coefficients of one variable match but are opposite signs. Add the equations together. Solve for the remaining variable. Back solve for the other variable. And check. Sorry, I kind of squish that in there. You may need to pause this video to write all that down, but the good news is this makes more sense in practice than anything else. So if you need a pause. Okay, so looking at this, I want to make the coefficients of one of my variables the same, but opposite signs. So I try and look at this and I try and decide what's going to be easiest. Well, what is the smallest number that both 4 and 2 go into? The least common multiple. Well, the least common multiple here would be 4. And the least common multiple for 5 and 3 would be 15. One of these requires me to multiply one equation to get to it, and one requires me to multiply both. So I pick the one that only requires me to multiply one equation. So first of all, notice that step 1, which these are the official step 1s, require both equations to be in the form ax plus by equals c. So do notice that you do need to start with that, because if it's not in that format, you can't do the addition method. Okay. So step 2 officially is multiply either equation or both. Okay. So we said that getting the leading coefficient, the coefficient in front of the x's, both to 4 is going to be the way to go. Okay. So 4x plus 5y equals 3, we're going to keep exactly how it is because the number in front of x already is 4. But I want to figure out, what do I need to multiply the second equation through by? Well, I want the coefficient to be 4, but I also need it to be the opposite sign. So to make it both 4 and negative, I need to multiply through by -2. So when I take 2x minus 3y equals 7 and I multiply it by -2, I get -4x plus 6y equals -14. And notice that's because I'm distributing the -2. Now I'm going to line my two equations up, the two rewritten versions, and I'm going to add straight down. Notice the 4x's now cancel. And I have 5y plus 6y is 11y, and 3 plus -14 is -11. To solve for y, I'll divide by 11 on both sides. Okay, so we get y equals -1. But once you have one letter, one variable, you need to go back and use that to solve for the other one. So we're going to back substitute and find the value for the other variable. So 4x plus 5y equaled 3. I'm going to replace my y with -1. And I get 4x minus 5 equals 3. I can add 5 to both sides. 4x equals 8. I divide by 4, and x equals 2. That means my answer is going to be 2, -1, assuming it checks okay. Now notice we used 4x plus 5y to solve for x. So for my purposes on my tests, you are allowed to skip checking that because you literally just used it. As long as it works in the other equation, now you're good. So I plug in 2 for the x and -1 for the y. I work my way down. It does indeed work. Yay! So we can keep 2, -1 as our answer. Now, there are 3 situations you can have with linear systems. Okay? So it is possible that your 2 lines will intersect once, and that will give you one solution to the system. It is possible for your 2 lines to never intersect because they are parallel. That means there's no solution to the system. And it's also possible for your 2 lines to be exactly the same line laid one on top of the other. That will give you an infinite number of solutions. Okay? So, notice, one solution, no solutions, infinitely many solutions. That's where, again, the 2 lines literally lay on top of each other. They're exactly the same line. So let's take a look at an example that you might see that has no solution. So in this system, I see that this kind of looks like it should be solved by addition because it's already in the correct format. So I asked myself, okay, what could I multiply through by to make the coefficients match but be opposite signs for one of my variables? Well, I'm going to multiply my top equation through by 2. You notice when I distribute my 2, I get 10x minus 4y equals 8. And I'm going to keep my second equation, and I'm going to add them together. That gives me 0 equals 15. 0 does not equal 15. That's not possible. Therefore, this has no solution. Remember, when it's no solution, we call the system inconsistent. So sometimes we write a no solution answer as the solution is an empty set. The empty set symbol is a 0 or an O with an X out through it, okay? So note that this symbol here means empty set. Now, if we were to look at the graph of this, you would see that these two lines do not intersect, which confirms that it has no solution. Now let's take a look at an example with infinitely many solutions. When you look at this, you're going to notice that it's set up to be a substitution problem because we already have one letter solved for. So since x equals 4y minus 8, I'm going to replace this x with 4y minus 8. So I have 5 times 4y minus 8 minus 20y equals negative 40. I need to distribute the 5. And then I'm going to be able to combine like terms. 20y and negative 20y cancel. That gives us negative 40 equals negative 40. Well, that is always true. Because it's always true, okay, then we can say that this is an infinite number of solutions, okay? So any solution that works is part of an infinite number of solutions. So it's a lot of answers, okay? Now, when we actually graph this, you're going to notice that it looks like two of the exact same line. Now, one of the things we use this for in our real lives is to find a break-even point. A company that manufactures running shoes has a fixed cost of $300,000. So that's how much they have to spend to keep their company running, even if they're not making anything. Additionally, it costs $30 to produce each pair of shoes. They are sold at $80 per pair. Write the cost function C of producing X pairs of running shoes. Well, first of all, C is for cost, so we only use the numbers that involve costs. So it costs $300,000 plus $30 per shoe. So if I'm making one pair of shoes, or for each pair of shoes, if I make one pair of shoes, that's $30. If I make 2 pairs of shoes, that's $60. 3 pairs is $90. So notice that what you're doing is you're taking 30 and you're multiplying it by the number of shoes. So we can write our cost function to be 300,000, the fixed cost, plus the marginal cost, or the cost per shoe, times the number of shoes. That is where this equation came from. So that's our cost function. The next thing they want us to do is to find the revenue function. By definition, revenue is how much money you are bringing in. So I'm selling my pairs of shoes for $80 each. So my revenue function is 80 times the number of shoes, 80x. Now, I want to determine the break-even point. the break-even point is the point where the two functions, the cost and the revenue, are at the same point, okay? So we want to find where C and R intersect. So we can solve this system by doing any of the methods we've learned so far. For our purposes, to make it easier to figure out, we are going to set C of x and R of x both equal to y. So we're replacing the function notation with y equals. Now, I can set these two functions equal to each other because y equals 80x can be substituted in, okay? So that makes it a lot easier for us to solve. We can subtract 30x from both sides and then divide by 50, and we get that x is 6,000. Since x is 6,000, we can plug that back into the simpler of the two y equations and say that y is 480,000. So we know we have the point 6,480,000. But what does that mean in the context of the problem? We need to write an answer as a sentence. So since 6,480,000 is our point, our break-even point, we can say this means that the company will break even if it produces and sells 6,000 pairs of running shoes. And the $480,000 is how much money we are bringing in, the revenue, okay? Because that matches at this point the cost of making 6,000 pairs of running shoes. After this point, every pair of running shoes becomes profit. So let's see what we can do about practicing these. Go ahead and try solving this one by the substitution method and come back here to get your answer corrected. So in this case, they've already solved for y. So I'm going to substitute that in. X minus 2 times 2x minus 18 equals 3. I need to distribute the negative 2, and do notice that that negative comes with the 2. So this is x minus 4x plus 36 equals 3. I combine like terms, I get negative 3x plus 36 equals 3. I subtract 36, negative 3x equals negative 33. I divide by negative 3 and I get x equals 11. At this point, I say, okay, no problem. I still have to find my y though, okay? So I have y equals 2 times 11 minus 18. 22 minus 18 gives us 4. So y equals 4. That means my answer is 11, 4. But before I box it, I need to finish checking it. Notice that I already used 2x minus 18 to solve for y. So I'm going to check in my other equation. So x is 11 minus 2 times y is 4 equals 3. Maybe. I hope so. So question mark. 11 minus 8 equals 3. Well, 11 minus 8 does equal 3. Yay, it worked. I get to keep and box my answer. Try solving this by the addition, also known as elimination, method, and then press play when you're done. So, for me, I decided to get rid of the x because I thought I could multiply just one equation through by something to get rid of the x. Now, the coefficient here is 1, and the coefficient here is 4. So to make them cancel, I need to find the smallest number that they both go into, which is 4. And so I need them to both be 4, but I need one of them to be a negative. So I'm going to multiply the first equation through by negative 4. That gives me negative 4x minus 8y equals negative 12. And I can carry down 4x plus 3y equals 7. Now when I add these together, I get negative 5y equals negative 5. I divide by negative 5 on both sides and I get y equals 1. Now I need to solve for x. I'm just going to plug into the top equation. See no reason not to. So I have x plus 2 times 1 equals 3. X plus 2 equals 3. I subtract 2 from both sides. X equals 1. That means my answer is going to be 1, 1, assuming it checks. So I'm going to check it in my second equation since I used the first equation to solve for x. So I have 4 times 1 plus 3 times 1 equals 7. 4 plus 3 equals 7. Well, 4 plus 3 is 7, so yes, that works. I get to keep and box my answer. Use this graph to solve this problem. So, this wants to know how many radios must be produced and sold for the company to break even. Notice that your graph involves the cost and the revenue functions. So breaking even is when the amount of money you're bringing in equals the amount of money you're spending. So I look at this and I say, okay, no problem. I'm looking for this intersection right here. Now looking at the graph, I can see that it's almost 500, but I need to figure out the exact value. So they gave me the equations for my cost function and my revenue function. So for my purposes, I just need to set them equal to each other and solve. So 13,300 plus 6x equals 44x. I'm going to subtract 16x from both sides. That gives me 13,300 equals, and 44x minus 16x is 28x. Now I just need to divide both sides by 28. And when I do that, I get, I think a number that comes out nice. Yes, I do. This comes out to 475 equals x, which if we look at our graph, 475 does seem reasonable. And we did want to make sure we knew how to solve it, though, because I could have guessed 480 or 460. I know now that is exactly 475 radios. Notice that this was a word problem, our answer is a sentence. So the number of radios that must be produced and sold in order to break even is 475 radios. So if we have a manufacturer who creates small canoes and they have a fixed cost of $22,000 and it costs $20 to produce each canoe, and each canoe can be sold for $40, okay? I want you to find the cost function, the revenue function, and the break-even point. So the cost function is 22,000 plus 20x, okay? Because this is the fixed cost plus the marginal cost times the number of canoes. Notice that they are telling us to use x as the variable here, so that's why we know it's x. The revenue function says that I'm selling it for $40 per canoe. Obviously, these are very small canoes. Now, to find the break-even point, I want to know where the cost and the revenue equal each other. So I'm going to set 22,000 plus 20x equal to 40x. I subtract 20x from both sides, and I get 22,000 equals 20x. I'm going to divide by 20, and x equals 1,100. So we know that we need to sell 1,100 canoes. Now, the next question is, what does that mean for my break-even point? Because that was just the x value. So I'm going to plug it back into one of my formulas. Okay, I'm going to plug it into revenue because that's easier to work with. So revenue at 1,100 canoes is 40 times 1,100, which gives me 3 zeros because I have 40 and 1,100, and 4 times 11 is 44. So my break-even point is at $44,000. Notice that you don't put units there, okay? If they ask you to write a sentence, you do write a sentence. Now, this one will definitely be a sentence. Go ahead and read it and try it. There's a 6,000 seat theater and it has tickets for sale at $26 and $40. How many tickets should be sold at each price for a sellout performance to generate a total revenue of $178,400? So first of all, there's two types of tickets. We're going to call them X and Y. And we know ticket X plus ticket Y equals $6,000. Okay? And I know that my revenue is $178,400. And I know that I can sell ticket X for $26 and ticket Y for $40. So $26 times the number of those tickets plus $40 times the numbers of those tickets will add up to $178,400. If you didn't get these two equations correct, pause the video again and try solving. So I want to find out how I can solve this. Well, for me, I'm looking at this and I'm thinking, okay, I'm going to use the addition method. And I'm going to get rid of either the X or the Y. Now, personally, I usually go with the number that's smaller. However, in this case, I'm going to multiply both sides of the top equation by -40 to get rid of the Y, because multiplying by -40 is easier than multiplying by -26, which would be my option to get rid of the X's. So when I distribute that, I get -40x minus 40y equals, and -40 times -6,000 is negative, and I have 24, and it has 4 zeros. So 1, 2, 3, 4. So now I can add down, and I get -14x equals, and 178,400 minus 240,000 is -61,600. And then I can divide both sides by -14, which comes out to be 4,400 tickets of type X. So what is my Y value? Well, I know X plus Y equals 6,000. So 4,400 plus Y equals 6,000. I subtract 4,400 from both sides. I say ticket Y is going to be a total of 1,600 tickets. Okay, so at this point we can write a sentence. I need to sell 4,400 $26 tickets and 1,600 $40 tickets to get a total revenue of $178,400. All right, that's systems of equations with 2 variables. Next up, systems of equations with 3 variables.